Hello everyone, in this video we're going to be doing 9709 Pure Maths 3 paper 33 October November 2023. This paper is 1 hour 50 minutes, so excuse me, we will be trying to finish the paper within the time limit, so without further ado, let's begin. Okay, so the first question is an inequality involving a modulus function. So we have to find the set of values of x, and our answer should be 2, 3SF. Okay, so how we solve this is first we are going to solve 2x plus 1 minus 2 less than 0.5. We move the 2 over to the other side, so we would get 2.5. Now we take ln on both sides, and we can bring down the x plus 1 power, so it will be x plus 1 times ln 2 less than ln 2.5. And now we can divide both sides by ln 2, and since ln 2 is positive, the sign does not change, so it still remains this less than sign. And now we finally minus by 1 to get our final answer. So type it into your calculator. You will get 0.322 to 3SF. And for our second case, we are going to do 2x minus 2x minus 2 bracket less than 0.5. Okay, so first step we can do is to divide the negative 1. So we would have the negative sign gone and the inequality sign flipped, and the negative goes over to the other side. And we also apply the same procedure here, so let's do that. So this side would be 2 minus 0.5, which is 1.5. Take ln on both sides, and bring down the power. So our second part of the answer would be x is more than, negative 0.415 to 3SF. Hence our final answer would look something like this. Or you can just leave it like this. Okay, so we're done. Let's head on to the next question. Okay, so this is an Argand diagram question where we have to draw the locus satisfying these two inequalities. Let's look at the first inequality. So first, let's factor out the negative 1 from both sides. So we would have z minus bracket 1 minus 2i is less than or equal to z minus 0 plus 0i. So this yeah, excuse me. So this inequality is basically the perpendicular bisector of one -2 and 0, 0, basically the origin. So how do we find the perpendicular bisector equation? So I prefer to do it this way. I would let z be equal to x plus iy minus 1 plus 2i more than or equal to x plus iy. Now let's rearrange and group the real and imaginary terms together. And now let's use the formula for the modulus of a complex number. So this would be square root x minus 1 squared plus y plus 2 squared less than or equal to square root of x squared plus y squared. So the square roots will cancel out, and okay, let's continue it here. Let's expand out the brackets, so it will be x squared minus 2x plus 1 plus y squared plus 4y plus 4 less than or equal to x squared plus y squared. Now we can subtract x squared plus y squared from both sides, so this will cancel, and this will cancel. So our final answer would be this. And now we're going to make y the subject of the equation. So let's do that. So this would be 4y less than or equal to 2x minus 5. Then y would be less than or equal to 1/2 x minus 5 over 4. So this will be the Cartesian equation of our perpendicular bisector. Okay, now let's focus on this one. So this, we'll also do the same procedure, factor out the -1, so we'll get 2 plus 0i less than or equals to 1. So this one would be a circle. Okay, wait. Alright, let me write here. So this would be a circle with center 2, 0. So basically 2 on the y-axis. Wait, no, sorry, on the x-axis. And radius would be equal to 1. And it would be a bolded circle. It's not going to be a dashed one since the inequality sign has equals to. Same for the perpendicular bisector. So with that in mind, let's start sketching our Argand diagram. Use the whole space provided, and if you can, I would strongly suggest you use a ruler. But since I don't have one here, I'm just going to do it freehand. Okay, let's start labeling our axes. So 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Now let's do it for the imaginary axis. 1, 2, 3, 4, 5, 6, 7. Now let's do for the negative imaginary axis. 1, 2, 3, 4, 5, 6. Okay. Let's sketch the circle first. So that would be 1, 2. So the center is here. And the boundaries of the circle would be here, since the radius is 1, and here, and here, and here. So let's sketch the circle. Okay. Alright, so this is our circle. Now let's draw the perpendicular bisector. So first we're gonna have to find out the x and y intercepts. So just substitute x equals to 0 into this equation. You would get minus 5 over 4 as your answer. So that is between 1 and 2. That's about negative 1.25. So, okay, it'll be somewhere here. Now let's find our x-intercept. So just equate y equals to 0. We would get 5 over 4 times 2, which is 5 over 2. That would be 2.5. So 1, 2, 1, 2, 3. So somewhere here. And now let's join up those points together. Sorry. Okay. All right. Okay, so this is our perpendicular bisector, and since the inequality sign says less than or equal to, the region we're looking for is below this line. So combining inside the circle and below this line, our region would be this. Oh, and don't forget to plot your points for the perpendicular bisector. So try labeling the origin as well as 1, comma, negative 2. So that would be 1, negative 2. So somewhere here. Yep, that's a perpendicular bisector. So we're done with this question. Let's head on to the next one. Okay, so here we have this polynomial and a px, and we're told that when it's divided by x plus 2, the remainder is negative 38. And when it's divided by 2x minus 1, remainder is 19 over 2. And we should find the values of a and b. Okay, so here we have to use our remainder theorem, which basically states that if ax plus b is divided by px, you're supposed to equate it to 0 and solve for x and substitute into px. You will get the remainder. So, okay, let me erase this. So let's do that for both of them. Okay, so x plus 2 equals to 0. We would get x minus 2. And now let's substitute x minus 2 into px. So let's do that. And this would be equals to the remainder, which is negative 38. Let's simplify it now. Negative 16 4a minus 2b plus 6 equals to negative 38. Let's isolate the a and b terms together. So the right hand side would basically just be negative 28. Now let's divide the entire thing by 2. Get 2a minus b equals to minus 14. And now let's make b the subject. So that would be 2a plus 14. So this is our first equation. Now let's do the same thing with 2x minus 1. So equating it to 0, we get x equals to 1 over 2, and we'll substitute x equals 1 over 2 into px, and we will equate it to 19 over 2 this time. So let's do that. Now let's simplify every term. And multiply the entire thing by 4. So we get 1 plus a plus 2b plus 24 plus 19 times 2, 38. Now let's isolate the a and 2b. We would get 38 minus 24 minus 1, which is 13. So this is our equation 2. And now we can substitute equation 1 into 2. So we will get a plus 2 times 2a plus 14 equals to 13. Now we can solve for a. So we would get 5a equals to 13 minus 28, which is negative 15. And this would give us a equals to negative 3. And now we can substitute this result into equation 1 to obtain our b. So b would be 2 times a plus 14, okay, and this would get us 14 minus 6, which is 8. So this would be our answers for a and b, negative 3 and negative 8. Let's head on to the next question. Okay, so now we're given this complex quadratic equation, and we would have to find the values of w, and we have to give our answers in the form x plus iy, where x and y are real. Okay, so let's write down the quadratic equation first. So let's start listing our a, b, and c values, then we can substitute it into the quadratic equation. So here our a would be 3 plus I, our b would be minus 2, and our c would be 3 minus I. So now we can find w using our quadratic formula. So minus b, which should be 2, plus minus square root of b squared, which would be 4 minus 4a c over 2a. So now let's simplify this. So we have 2 plus minus 4 times square root of 4 minus 4. Let's expand the 3 plus 8 and 3 minus sorry. So this would just be 3 square minus I square. So that's just 9 minus negative 1, which would give us 10. And let's expand the brackets in the denominator. We would get 6 plus 2i. Now let's simplify the root. You will get 4 minus 40, which is negative 36, over 6 plus 2i. So this would eventually simplify to 2 plus minus 6i over 6 plus 2i. Now let's write down both positive and negative versions. So first we would have 2 plus 6i over 6 plus 2i. And the second value would be 2 minus 6i and 6 plus 2i. Okay, so in order to simplify this, we're going to have to multiply the denominator by its conjugate. So in this case, we're going to have to multiply both the numerator and denominator by 6 minus 2i. That way our denominator would be real, which would make things easier for us. So the denominator, if you realize, it's in the form of a plus b times a minus b. So we can simply write a squared minus b squared. So in this case, a squared would be 6 squared, which is 36, and then minus b squared, which would be 4i squared. And 4 times I squared is just 4 times negative 1. So it would just be negative 4. And negative minus negative 4 is plus 4. So our denominator will be 40. Now let's work out the numerator. So we'll have 12, 2 times negative 2i minus 4i, and 6i times 6 would be 36i, and 6i times negative 2i, that would be minus 12i squared. And I squared again is times negative 1. So minus 12 times negative 1, it would be plus 12. Okay, now let's simplify everything. So we have 24 plus 32i over 40. And just split up the fraction and we get our first answer. So we'll get 3 over 5 plus 5 over 4 over 5i. So this is our first answer. Now let's obtain our second answer. So we have the same denominator, so we're going to multiply by the same conjugate for this one as well. As we found out from the previous part, our denominator would just be 40. So we just have to work out the numerator. So 2 times 6 is 12. 2 times negative 2i is negative 4i. Negative 6i times 6 is negative 36i. And negative 6i times negative 2i is 12i squared. And 12 times I squared is just 12 times negative 1. So we will get minus 12 instead. So let's simplify everything in here. So we'll have no real part, so it'll just be 0, and the imaginary part would be negative 40i. So the 40's cancel out, we'll just have negative I. So this is our second answer, and we're done with this question. And if you want to check this, your answers, you can just substitute these solutions back into the original equation by setting your calculator to complex mode. So let's move on to the next question. Okay, so here we have to find the exact coordinates of the stationary points of this curve. Okay, so to find stationary point, we're gonna have to make dy dx equals to 0. So first, let's write down the equation. And now we can find our dy dx. So if you can see here, our equation is a rational function. So we'll have to use the quotient rule for this. So first of all, square the denominator, and in the numerator, keep the denominator, differentiate the numerator, so that would be just 6x e 3x squared minus 1 minus or the derivative of the denominator, so that would be minus 2x and times the numerator, which should be 3 e to 3x squared minus 1. Let's simplify things in here. And now let's equate this to 0. So we can multiply throughout by the denominator, and we would just have the numerator left. So in order to solve this equation, we are going to have to look for a common factor that we can factor out. In this case, we can see that we can factor out 2x times e to the power of 3x squared minus 1, as well as from here. So let's do that. So we would have 3 times 1 minus x squared plus 1 equals to 0. Now let's simplify this. We would get 3 plus 1 minus 3x squared equals to 0. We would have this as our final factorized expression. Now let's equate both factors to 0. So for this one, we know that e to the power of 3x squared minus 1 can't be equals to 0. So we can just divide it by 0. We'll divide it throughout. So we'll get 2x equals to 0, and hence we'll obtain x equals to 0 for this. Now let's solve the other part. So let's isolate 3x squared, get 4. X squared would be 4 over 3, and x would be plus minus 2 over square root 3. Okay, so we have to find the coordinates, not just the x coordinates, so let's substitute back into the equation to find our y coordinates. So for this one, we would have e times 3, 0 squared minus 1 over 1 minus 0 squared. So we would have, this would become 1, and this would just be e to the power of negative 1. So this is our first answer. Okay, and now we can find the y coordinate for each of these points in here. So we'll just substitute x squared to make things easier. So 3 times 4 over 3 minus 1 over 1 minus 4 over 3. So 3 cancels out, so we would have 4 minus 1, so e to the power of 3 over 1 minus 4 over 3, which is negative 1/3. So divide by negative 1/3 is the same as multiplying by negative 3. So we'll have negative 3 times e to the power of 3. Hence, our 3 coordinates would be 0, comma, e to the power of negative 1, 2 over square root 3, comma, negative 3e to the power of 3, and finally minus 2 over square root 3 comma negative 3 times e to the power of 3. So these are our answers. Let's head on to the next question. Okay, so here we have this trig equation, and we have to show it can be expressed as this. Okay, so first let's rewrite everything in terms of sine and cosine first. So cotangent square, we can write it as, okay, let's just write down the equation first. And now we can express everything in terms of sines and cosines. So cotangent square would just be cosine squared theta over sine squared theta. And for cosine 2 theta, we can actually just express it in terms of sine, since they want us to show an equation purely in terms of sine. So let's head on to our formula list. And as you can see, we have cosine 2a equals to 1 minus 2 sine square a. So let's write that down. So this would just be 1 minus 2 sine square theta equals to 4. Now let's open up the brackets. Sorry. Okay. So we have 2 minus 4 sine square equals to 4. Now let's multiply throughout by sine square. So we'd have cosine squared theta plus 2 sine squared theta minus 4 sine to the power of 4 equals to 4 sine squared theta. And now we can express the cosine square in terms of sine square using this identity right here. So cosine square would just be 1 minus sine square. And now we can rearrange everything by moving everything over to the right hand side. So we would have 4 sine 4 theta and 4 sine square minus 2 sine square plus sine square would just be plus 3 sine square theta and minus 1, which is equal to 0. So we got this answer that the question asked us, so we can stop here and write down shown. Okay, let's head on to the next question. Okay, and now we're gonna have to solve this equation for this domain using our answer from the previous part because of the word hence. So as you can see, this equation is exactly the same as what we had to prove. So we can just rewrite this equation as our result from the previous part. So here let's try to factorize it. Okay, so we got 4 sine squared theta. Okay, actually, alright, so if you can't see this, this is actually a hidden quadratic in terms of sine square. So by factorizing, we can find out our solutions for sine square. So by factorizing, we get 4 sine squared theta minus 1 times sine squared theta plus 1. So let's equate both sides to 0. So first one we would have sine squared theta equals to 1 over 4. For the other side, we would have sine squared theta equals to negative 1. So as you can see, sine squared theta has to always be positive or more than or equal to 0. So we're going to have to reject this answer. And now let's find sine theta for this. So for that we would get plus minus 1 over 2. And for our domain here, we can accept both positive and negative values, because if we look at our unit circle, it covers all 4 quadrants. So for positive, it will be the first and the second quadrant, and for negative, it would be the third and the fourth quadrants. So we would have 4 solutions in total. Alright, so let's find our first theta. Basically just be sine inverse 1/2, and we're supposed to give our answer in terms of degrees since the domain is in degrees, so make sure to change the unit in your calculator to degrees. Okay, so first answer we get is 30 degrees. For the second answer, it would just be 180 degrees minus 30 degrees equals to 150 degrees. For the third answer, it would just be 180 degrees plus 30 for negative sine theta equals to negative half. So that would just be 210 degrees. And finally, for the fourth quadrant, 360 minus 30 degrees, we would get 330 degrees. So these are our final answers. And if you want to check them, just substitute it back into the original equation. Okay, let's head on to the next question. So we're given this equation of a curve implicitly, and we have to find dy dx for the first part. Okay, so let's write down the equation of the curve first. And let's take dx on both sides. So first we'll be differentiating x cubed with respect to x. So that would just be 3x squared. For the second term, in order to differentiate y squared with respect to x, we're first going to be differentiating with respect to y. So that would just be 2y. And now we're going to have to multiply dy dx. This is according to the chain rule. For the fourth term, we would just get 6x. The third term would get 6x. And for the final term, again, we'll just differentiate with respect to y first. So we get 3 and multiply dy dx. And the last term is just a constant, the right hand side, so it would just be 0. And now let's collect all the terms in dy dx and move the non-dy dx terms to the other side. So we would have minus 3x squared minus 6x. So let's factor out dy dx. We have 2y plus 3 equals to Let's factor out the negative from the right hand side, so it will be 3x squared plus 6, and we would get our final answer for dy dx. 3x squared plus 6 over 2y plus 3. So this is our final answer, and we can write shown here. Okay, and now we're gonna have to find the coordinates of the points at which the tangent is parallel to the x-axis. So what does it mean when the tangent is parallel to the x-axis? So at that point, it means the gradient of the point of the curve is 0, and hence dy dx at that point should be equal to 0 as well. So let's start by equating dy dx to 0. So we can multiply the denominator throughout to get negative 3x squared plus 6 equals to 0. Get rid of the negative sign. Get this. Oh wait. Oh no. Oh sorry. Okay. Yeah, I forgot the x right there. So let's put the x. Okay, now it makes a lot more sense. Now we can solve this equation by factoring out 3x. Then we'll have x plus 2 equals to 0. Now we'll equate 3x to 0. We'll get x equals to 0, and x plus 2 equals to 0, and x equals to minus 2. So these are our answers. And now let's write down the equation of the curve. So we'll have x cubed plus y cubed plus 3x squared plus 3y equals to 4. And now we are going to be substituting these two x values into here. So let's substitute x equals to 0 first. So that would be 0 plus y cubed plus 3 times 0 plus 3y equals to 4. Okay, let me double check. Oh, again, sorry about the error. It should be y squared. Okay, let me double check again. All right. Yeah, so this would be y squared. So moving everything to the left hand side would get y squared plus 3y minus 4 equals to 0. Now let's try to factorize this. We will get y minus 1 times y plus 4 equals to 0. Now we can equate both of these to 0, and we would get y equals to 1 and y equals to negative 4. So these are our first set of answers. Now let's substitute x equals to negative 2 into 1 instead. So we would have minus 2 cubed plus y squared plus 3, oh wait, 3 minus 2 squared plus 3y equals to 4. So simplifying the constant terms, oh, wait, sorry, we would get 4 plus y squared plus 3y equals to 4. let me, minus 8 times 4, 12, minus 8, that's 4. So the 4's cancel out, and we would have y squared equals plus 3y equals to 0. So we can factorize it, y plus y times y plus 3. We would get y equals to 0, or y plus 3 equals to 0, which would give us y minus 3. So this is our final set of answers, and our coordinates would be 0, comma 1, 0, comma negative 4, minus 2, comma 0, and finally minus 2, comma minus 3. So these are our 4 answers, and let's head on to the next question. Okay, so we have this differential equation that we have to solve, and we're given the initial conditions in here, and we're supposed to obtain an expression for y in terms of x, so we'd have to make y the subject. Okay, so first let's write down the differential equation. And now let's separate the variables. So let's move the dx to the other side. And let's move the cosine square 3y to the other side and the e to the 4x to the other side. So we would have 1 over cosine square 3y dy equals to 1 over e to the power of 4x dx. So we can integrate these. But we can simplify this further to make our integration easier. So this left hand side, we can write it as the integral of secant squared 3y dy equals to the integral of e to the power of negative 4x dx. Okay, so for the left hand side, it would just be 1 over 3 tangent 3y plus c. And for the right hand side, it would be minus 1 over 4 e to the power of negative 4x. And now let's substitute the initial conditions. So we would get tangent 3 times 0, so that's just tangent 0, plus c equals to negative 1 over 4 e times 4 minus 4 times 2. So tangent 0 would just be 0, so we'll have c by itself. So c would be 1 over 4 times e to the power of negative 8. And hence, we will get our final equation. So let's isolate 1 over 3 tangent 3y first. So that would just be 1 over 4 e to the power of negative 8 minus 1 over 4 times e to the power of negative 2. Now let's multiply both sides by 3. We'll get 3 over 4 e to the power of negative 8 minus 3 over 4 times e to the power of negative 4x. And let's take the inverse tangent on both sides. And our final answer would be 1 over 3 times tangent inverse 3 over 4 times e to the power of negative 8 minus e to the power of negative 4x. So this is our final answer. And now we can head on to the next question. Okay, so we're given fx as a rational function, and we're supposed to express fx in partial fractions. Okay, so let's compare the degree of the numerator and the denominator. So for the numerator, it would be 2. For the denominator, it would be 3. So we don't have to do any long division for this one. So we can get straight into decomposing. So for the first factor, since it's a quadratic that cannot be factorized, the numerator would be a linear term in the form of ax plus b. And the second factor, since it's a linear term, the numerator would just be a constant. Okay, so now let's multiply throughout the equation by the denominator. So you get ax plus b times 2 minus x plus c times 2 plus 3x squared. Okay, so first we can make the 2 minus x equals to 0 by substituting 2. So let's substitute 2. And by doing that, this would be 0, and we don't have to get a term in terms of a and b. And we can just focus on finding c. So let's do that. So we'll have c times 2 plus 3 times 2 squared. So 2 squared is just 4. 4 times 3 is 12. 12 plus 2 is 14. On the left hand side, just type it into your calculator. You would get 7. And hence c would be equal to 5. Okay, and now, okay, there isn't really a way to make this 0, nor this. So the next best thing we can do is we can substitute 0. So if you encounter this situation where you cannot make any of the factors 0, always go with 0, 1, or negative 1. Whichever one you haven't used already, then it would make it easier for you to solve for the remaining unknowns simultaneously. Okay, so a times 0 would be 0, then we'll just get b times 2, so just 2b, and then c would be 5. 2 plus 3 times 0, so it'd just be 2 times 5, which is just 10. And the left hand side would be 17 times 0 squared minus 7 times 0 plus 16, which is equal to 16. And 2b would be equals to 6. Hence, b would be equals to 3. Okay, so now we only have a left to find. So let's do that by substituting x equals to 1. So we would have a plus b, which is 3, 2 minus 1, which is just 1, plus c, which is 5, times 2 plus 3, which is 5. So 5 times 5 is 25. And for the left hand side, it would be 17 minus 7 plus 16. which is 26. And now we can just solve for a, so it would be just 26 minus 25 minus 3, which would be minus 2. So we have found all our constants. Now we can express fx in terms of partial fractions. And our final answer would be 3 minus 2x over 2 plus 3x squared plus 5 over 2 minus x. So this is our final answer. Okay, and now using our answer from the previous part, because of the word hence, we have to obtain the expansion of fx in ascending powers of x up to n, including the term in x cubed. Okay, so for this question, we would have to use this formula for when the power n is rational. So we would just need to use up until here. So 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed. Okay, so first of all, let's write down fx in terms of rational powers. So this would just be 3 minus 2x times 2 plus 3x squared to the power of negative 1 plus 5 times 2 minus x to the power of negative 1. So in order to use the formula, our constant term has to be equal to 1. So in this case, we're going to have to factor out 2. So this would just be 2 times 1 plus 3 over 2 x squared to the power of negative 1 plus 5. For this term, we're also going to have to factor out 2. So we'll have 2 times 1 minus x over 2 to the power of negative 1. So now we can distribute the power negative 1 to both the 2 and this bracketed expression. So we would have 1/2 times 1 plus 3 over 2x squared to the power of negative 1. So it would look something like this. And same for this, so this would just be 5 times half, which is just 5 over 2 times 1 minus x over 2 to the power of negative 1. Okay, and now it's time to expand the negative powers. Okay, so since we just want including the term x cubed, for this one we're just gonna expand up until the first two terms. So this would just be 1 plus n times x, so n is minus 1 and x would be 3 over 2x squared. And if we get the next term, we would have a term in terms of x squared squared, which is x to the power 4, which we're not interested in. Dot dot dot. And for this one, we're gonna have to obtain the first three terms. So this would be 1 minus 1 times minus x over 2, so plus x over 2 plus n times n minus 1 over 2 factorial minus x over 2. Okay, you know what, let's, alright, plus 5 over 2 1 minus 1 times minus x over 2, so plus x over 2 plus n, which is minus 1 times n minus 1, which is minus 2, over 2 factorial times minus x over 2 squared plus minus 1 times minus 2 minus 3 over 3 factorial times minus x over 2 cubed. So let's simplify. So we would have 1 minus 3 over 2 x squared plus 5 over 2 bracket 1 plus x over 2 negative 1 times negative 2 over 2 factorial, which is just 1. So we would have x squared over 4. And for the third term, it would be negative 1 times negative 2 times negative 3 over 3 factorial, which is minus 1. Minus 1 times minus 1 cubed, just be 1. So we would just have x cubed over 8. And now we can open up the brackets and expand. So this would be 3 over 2 minus x times 1 minus 3 over 2x squared plus 5 over 2 plus 5 over 4x plus 5 over 8x squared plus 5 over 16x cubed. Now let's just expand this out. So we would have 3 over 2 minus 9 over 4x squared minus x plus 3 over 2 x cubed plus 5 over 2 plus 5 over 4x plus 5 over 8x squared plus 5 over 16 x cubed. And the question said we have to expand, and we have to, our answer should be in ascending powers. So we are going to have to start with the constant terms first. So that would be 4. And now the x terms, it should be minus x plus 5 over 4, which would be 1 over 4x, and the x squared terms, which would just be minus 9 over 4 plus 5 over 8 x squared, which would be minus 13 over 8x squared, and the x cubed terms, it would be 3 over 2x cubed plus 5 over 16 x cubed, which would be 29 over 16 x cubed. So this would be our final answer for this question. Okay, and now, gosh, what's going on? Okay, so now we have to state the set of values of x for which the expansion in the previous part is valid, and we have to give our answer in an exact form. Okay, so let's look at our expressions right here. So one condition that is in the formula booklet, it is basically states that the modulus of x would be less than 1. So you can write it as minus x can be between negative 1 or 1. Alright, so that means this has to be between 3 over 2x squared has to be between 0 and 3 over 2x squared and 1. So removing 3 over 2, you would get 0 x squared 2 over 3 x squared, we would get 0 x square root 2 over 3, or minus square root 2 over 3 x 0. So this is our first answer. And now for this one, it's basically just 1 minus x over 2. And in order to get this, just have to be minus 2 x 2. Okay, so combining these two inequalities together, we're gonna have to reject this and this. Wait. Combining these two, we're gonna have to combine these two inequalities, and hence answer would be negative 2 square root 2 over 3 and positive square root 2 over 3. So this is our final answer. Let's head on to the next question. Let's see how many questions we have left. Okay, we still have 2 more. Alright, so here we have this curve y equals to x cosine 2x for x more than or equal to 0. First of all, we have to find the equation of the tangent to the curve at the point where x equals to pi over 2. So in order to find the equation of the tangent, we have to find the gradient of the point over there. So we are going to have to find out dy dx at that point. So let's write down our original function. And now let's find our dy dx. And since this function is expressed as a product of two other functions, we're going to have to use our product rule. So here I'm going to keep x first and differentiate cosine 2x. So that would just be 2 times minus sine 2x. And now I'm going to differentiate x, which would just be 1, and keep cosine 2x. So that would just be cosine 2x. And now let's simplify this expression. 2x sine 2x. Okay, and now let's substitute x equals to pi over 2. So dy dx would be equal to cosine 2 times pi over 2 minus 2 times pi over 2 sine 2 times pi over 2. So type it in your calculator. Okay, change it to a radian mode before you do so. This would be minus 1. This would be pi, and sine 2 times pi over 2 would just be 0. So our answer would be negative 1. So our gradient would be minus 1. And now we would have to find our c. Y equals to mx plus c. We're going to have to find out our c. Okay, so we're given the x coordinate, but we're not given the y coordinate, so we're gonna have to find out the y coordinate by ourselves. So y would just be pi over 2 cosine 2 times pi over 2. So that would just be minus pi over 2. And now we can just substitute into this equation right here. So minus pi over 2 minus x, which is again minus pi over 2 plus c. Hence our c would be equals to 0. And our final answer would be y equals to minus x. So this is our final answer. Let's head on to the next part. Okay, so here we're going to have to find the exact area of the shaded region shown in the diagram bounded by the curve in the x-axis. So basically we're going to have to find this area, and in order to do that we need to know these 2 points in here, which will be our limits. But we're not given the limit for this one, so first we're going to have to find out what that is. So let's equate x cosine 2x equals to 0. So we'll get x equals 0, which is our lower limit, but we're not interested in that, so we'll just reject it. And cosine 2x equals to 0. Okay, so cosine 2x would be giving us pi over 2. That's our least possible answer. So hence our upper limit would just be pi over 4. Okay, so now we're going to have to do our integration, which would just be pi over 4, 0, x times cosine 2x dx. Okay, so for this one, it's integration by parts, since we have again a product of 2 functions and we have to integrate them. Okay, so I'm going to let my x be u, and this will be dv dx. Okay, so let's find out our uv first. So that would be x times half sine 2x. So we'll get half x sine 2x. And don't forget to write down the limits. Minus v times du dx. So du dx would just be 1, so we'll just have to write v. So our v would just be minus half sine 2x dx, pi over 4 and 0. So this first part, it will basically be half times pi over 4 times sine 2 times pi over 4. And for 0, it will just be half times 0, and that will just give us 0. Now let's find out this integral. Pi over 4, 0 sine 2x dx. So let's evaluate this. Just be sine pi over 2, which is 1. So this would just be pi over 8 minus 0, which is just pi over 8, and minus half. And the integral of this would just be half times negative cosine 2x, so just minus half times cosine 2x pi over 4 and 0. So this would be minus half times minus half cosine 2 times pi over 4 minus minus half, which is plus half cosine 0. So we would get minus half cosine 2 times pi over 4, which is 0, and half cosine 0 would be half. So simplifying all this, we would get pi over 8 minus 1 over 4. So this is our final answer. And if you want to check whether your answer is correct, just type this original integral into your calculator and verify your answer. Okay, let's head on to the last question. Okay, so the line L has the equation this, and we have the points A and B, which have position vectors this and this respectively. Okay, first question, we're going to have to find a unit vector in the direction of L. Alright, so okay. Alright, so what is a unit vector? A unit vector is a vector whose magnitude is equal to 1. So in the direction of L, so lambda would be the scalar, and this is the direction vector of L. Now let's expand it and equate the magnitude to 1. So this would just be lambda squared plus 4 lambda squared equals to 1. So this would just be 6 lambda squared equals to 1. 6 lambda squared equals to 1. And we would get lambda equals to plus minus square root 1 over 6. So in this case, let's just substitute lambda equals to positive 1 square root 1 over 6. So that would give us this, and eventually this. So this is our final answer for this part. Okay, and now the line M passes through the points A and B, and we have to find a vector equation for M. Okay, first of all, we're gonna have to find the direction vector for AB. So that would just be OB minus OA. So OB would be 3 minus 1, 1 minus OA, which would be minus 2, 2 minus 1. And that would give us 5 minus 3 and 2. And hence we obtain our vector equation. So first we're gonna have to start with the position vector of either one of these points. So here I'm gonna go with OA. So OA would be minus 2, 2, minus 1. And for the scalar, I'm going to go with mu. You can use any other letter as. So this is my final answer, and just to be safe, write down in terms of ijk as well. Plus mu 5I minus 3jk plus 2k. So this is our final answer. Okay, and now for the last question, we're gonna have to determine whether L and M are parallel or do they intersect or are skew. Okay, so recall that when two vectors are parallel, they're scalar multiples of each other. And when they intersect, the equations will be satisfied. Or the solutions will be consistent. And when neither of this happens, we only have one last possibility, is that they're skew. So first let's find out whether they're scalar multiples of each other. Okay, so L is basically, let's find the direction vector of L, which is minus 1, 1, 2, minus 1, 2. Okay, you know what, let's write down the vector equation for each of the vectors. So L would be this. Okay, it's basically 1 minus 2 minus 3. 1 minus 2 minus 3 times lambda minus 1, 1, 2 minus 1, 1, 2. And now we can expand it just in case we have to show that the equations will be satisfied. And let's do for M as well. So M would just be minus 2, 2 minus 1 plus mu times 5 minus 3 times 2, which is equal to 5 mu minus 2, 2 minus 3 mu, and 2 mu minus 1. Okay, so let's first prove that they're not scalar multiples of each other. It's not equal to k equals to 5 minus 3, 2. So L and M are parallel. Okay, so now let's determine whether they will intersect. Okay, so here we'll just equate the equations that we have made for each line. Okay, so let's equate these two equations first. So we would have lambda equals to 4 minus 3 mu. And now let's equate these two equations and solve them simultaneously. Okay, let's make lambda the subject again. So plus 3 minus 5 mu, 3 minus 5 mu plus lambda equals to 2. Okay, so now let's equate 1 and 2 together. We would have 4 minus 3 mu equals to 3 minus 5 mu. And that would get us 2 mu equals to 3 minus 4, which is minus 1. And that would get us mu equals to minus 1 over 2. Let's find out our lambda. It should just be 3 minus 5 times minus half. It should be 3 minus 5 times 1 over 2, which is 11 over 2. So now we will substitute. Okay, so we'll get 1 minus lambda, which is just plus 1 over 2, and minus half minus 2, and 2 times minus half minus 3 equal to this. Wait, oh no, sorry, I substituted the wrong values. Okay, so 1 minus lambda, 1 minus 11 over 2, 11 over 2 minus 2, and 2 lambda, which is just 11 minus 3. Is that equal to 5 minus half, which is minus 5 over 2 minus 2, 2 times 3 mu, negative 3 mu, which is plus 3 over 2, and 2 mu minus 1, which would just be minus 2. So let's simplify these. So minus 9 over 2, 2 minus 2, 7 over 2, 8 equals 2. Negative 9 over 2, 2 plus 3 over 2, 7 over 2, and negative 2. So as you can see, these vectors are equal, and so we can say, since the equations are not satisfied, lines L and M are skew. So this is our final answer. And we have also come to the end of this question paper as well. So I hope you enjoyed this video and found it helpful. And please make sure to like and subscribe for more solved past papers for A-level maths and further maths. And if you have any questions or would like to point out any errors or have any suggestions for future papers, please leave them down in the comment section below, and I'll see you again next time. Thank you.